Project is a heavy vehicle simulator for vibration study aid. A bit of background about myself: I'm a local Wollongong resident. I started uni in 2011. This is my 5th year. I'm doing a Bachelor of Mechatronics Engineering. Alright, my motivation for doing this project: it offers immediate assistance to PhD students currently experimenting with vibration reduction. And it offers me an opportunity to work with new and up-and-coming technology, namely the Oculus Rift and Unity 3D game designer. And it's a personal challenge in areas that I am inexperienced with. Alright, so an overview of the project. So lower back pain is a major issue in the US. It affects 12 million people in the country every year and is the leading cause of workers' absence for workers over 30 years old. One of the most common causes for lower back pain is the vibrations caused during the operation of heavy vehicles. And like I stated, there is a current project aimed at reducing these vibrations. My project is going to use a 6 degree of freedom motion platform to replicate both vehicle movement and vibration caused by movement over rough terrain. It will use Unity 3D game engine to create a virtual world and the Oculus Rift as a visual aid to immerse the user in the virtual world. Objectives of the project: to create a graphical user interface to control the platform. I need to create a sinusoidal transfer function to generate random vibration signals and create a virtual environment to immerse the user in, and finally integrating all these together to create the final product. So just a bit of information: the current system being developed, it uses a smaller version of the motion platform I'll be using. It features 6 actuators, and those actuators act in real time to counteract the movement from the pistons below. So my project is divided up into 3 main topics. One is the effect of vibrations on the human body. The second part is control of the 6 degree of freedom motion platform. And the third is the virtual reality component. Alright, so issues caused by the vibration on the human body. So being overexposed to vibrations causes lower spinal degradation. This weakens the lower support and results in long-term back injuries. It's the most common cause for worker absence in workers over 30 in the US. It affects 12 million workers each year, costing $5.6 billion in disability costs. Obviously, this makes it a big issue to be solved. Vibrations of this vehicle operated. The transmissibility of the vibrations is greatest at around 5 Hz. That's the resonant frequency through the human body, where it affects the spine at greatest. It's most likely to occur from vertical movement more than horizontal vibrations, and it is greater for the drivers than for passengers of vehicles. Due to the drivers holding the steering wheel, the vibration goes through the seat they're sitting on and through their arms. Alright, so the motion platform. Just a bit of a description: the upper platform is a hexagonal shape, which is connected to a larger hexagonal base by 6 SPS joints. SPS is just prismatic spherical, so the top 2 platforms are connected using spherical joints, and the prismatic joint creates a transitional movement along each leg. This design is the concept more commonly known as a Stewart platform, and it enables transitional movement along the X, Y, and Z axes, as well as pitch, yaw, and roll movements around the X, Y, and Z axes. So there's a couple limitations to the platform. Obviously, it can't replicate exact movements of vehicles, and the prismatic legs only have a plus or minus 40 millimeters movement. The later extensions are calculated using inverse kinematics in MATLAB and replicated on SimMechanics. Right. These limitations are overcome using the vestibular sense and the Mulder effect. So the vestibular sense contributes to a person's movement and balance, while the Mulder effect describes the inverse relationship between threshold for angular acceleration and movement. Basically, if you see something in your peripherals, you feel that sense of movement. To overcome these, the platform uses tilts and angles to represent velocities and physical movements to represent acceleration, and it can then reset back to a zero position slowly without your vestibular sense recognizing the platform movement. Alright, virtual reality. It's a relatively new concept, especially with HMD, head-mounted displays, still being developed. Virtual reality is described as a medium composed for interactive computer simulations that sense the participant's position and actions, providing synthetic feedback of being immersed in the simulation. Virtual reality all up improves the perceptual validity of a simulation, basically improving the user's immersiveness. The Oculus Rift and 3D game engine. So the Oculus Rift is a commercial, or soon-to-be commercial, virtual reality HMD. The aim of the Oculus VR company is to provide affordable and quality virtual reality headsets to the public. Unity 3D is the world's foremost game industry software. It takes up 45% of the world industry, and it's used to create the virtual environment. Together, these offer the greatest level of immersion in the simulation. So, the virtual and haptic cohesion in simulation. So this is the combination of both the platform movement and the virtual reality component. So this is all aimed at producing the simulation's validity and a thorough user immersion in the simulation. The idea is this helps trigger the vestibular sense and improve the overall validity of the experiment. The combination of the two creates an oculogiral illusion, which is, like I mentioned before, you see movement in your peripherals and you actually feel like you are moving yourself, and it tricks that into simulating movement. Future work to do on the project. So the virtual environment is still in its early stages. It needs to be fully developed with user movement. At the moment, it has the Oculus integrated into it, so the Oculus can be moved to look around the environment. The vibration signal needs to be done. The platform can be controlled at this stage, but the vibrations are yet to be introduced. And then finally integrating all this together, so movement around this virtual environment will cause the platform to move, the vibrations, and you can see it using the Oculus Rift. So conclusion, the Stewart platform is the most effective model for generating real-world motion and vibration in the simulation, the haptic feedback. The virtual reality and HMD significantly improve the project's validity, helping the user feel completely immersed in the simulation and movement. And all up, this will create a more efficient study for vibration reduction in heavy vehicles.